Let's take a look and see how you're doing. I realize some of you might not be completely done yet. But for the first one here, we have enclosing symbols. There's more than one, so we do left or right. So we're going to start with this one here. Inside there, we have another set of enclosing symbols. So we're moving inside this parentheses. In there, no more enclosing symbols, but we do have an exponent. 5 squared. So 5 squared is 5 times 5, or 25. And the rest of the problem is exactly how it is. So we're still working inside that inner parentheses. All that's left to do there is 27 minus 25, which is 2. Now in the same step, I've reduced what's in that parentheses down to a single number. I can take out the parentheses. I have to remember to put in multiplication there. So now we are back out to that larger set of parentheses. In there are no other enclosing symbols. There are no other exponents. Next is multiplication and division, going left to right. We have the 2 times 2 here, which makes 4. Now, inside that inner parentheses, the only thing that's left is addition and subtraction, so we will go left to right. 18 minus 4, 18. Last thing we have to do inside the parentheses is 14 plus 1, which makes 15. We're down to a single number in that parentheses now, so I can take out the parentheses. Once again, though, there's a number in front of the parentheses with no operation. That is implied to be multiplication. So we have to put that multiplication in there. No more enclosing symbols. No more exponents. Multiplication and division. We have 2 times 15, which is 30. I screwed up a little bit on this example. We haven't done negative numbers yet, but we'll muddle through here. 27 minus 30 is negative 3. And negative 3 minus 3 is a negative 6. So if you got to this part here, you did fine. We haven't discussed negative numbers yet, so I didn't really expect you to do the negative parts there. That's what I get for making up examples on the spot. Any questions on that one?
No.
Okay, back up to number 2 here. Number 2, remember this line across here is a fraction bar. It means divide, but it's also an enclosing symbol. So it means we have to do everything on top, everything on bottom, and then divide those two results. So let's do everything on top first. I'll bring it down here. First thing we have to do there is the 33 divided by 3, the division. Gives us 11. 45 minus 11 is 34. So the top of that is 34. On bottom, we have the exponent. 3 squared is 9. Then we have multiplication and division going left to right. 5 times 3 is 15. 18 divided by 9 is 2. And we have 15 plus 2 is 17. So the bottom is 17. And finally we divide. 34 divided by 17 gives us 2. Did anybody happen to do both and get them right? Get them both right? Cool. How many of you are confident you would have had them both right if I'd have given you more time? How many of you want to cry and go home? Nobody? Even if you got them right? Okay. Is there anybody that's really confused and wants me to go over either of those again? Okay, good. Now today what we're going to do is what I call a little bit of a workshop day. I'm going to have you grab out your large books, the big book. I'm going to do some stuff here today going back and forth with the big book, giving you some examples. You're going to do 5 or 6 problems, then we'll go over them. And that way we're moving to the class today. What we're going to talk about today, I want you to open up to about, starting at about page 51. As you're getting to that page, you're realizing that our topic for today is going to be starting with fraction. Now, we talked a little bit about fractions on Monday. We talked about having something like 3/4 and how that top number was a count. That's telling us we have 3 of something, just like having 3 inches or 3 cows. We have 3/4 here. There's the fourth, the 4 is the name. Just like the inches or the cows, we have fourths. So one of the first things we need to do is talk about what does it mean to have a name of a fourth. Well, the simplest way to do this is to go back to the old elementary school illustration. Pretend that's a circle of a pie or a pizza or however you want to imagine it, cut into 4 equal pieces. Each of those pieces is a fourth. So you can either look at it as every whole object gets cut into 4 equal pieces, or you can look at it as it takes 4 of these pieces to make a whole object. So then the 3 part of that means we have 3 of those pieces. So that's the visual definition of 3/4. Now, we also talked on Monday about we can only add or subtract fractions that have the same name. So one of the first things we need to be able to do is change the name of a fraction. The simplest way to do that is to look at that fraction and be able to divide it into smaller pieces. So I'm going to take each slice here and I'm going to cut them into 3 equivalent slices. Pretend each of these are equal slices. Now, as I look at that, how many pieces does it take to make up the whole pizza now? Yeah, if I numbered them out, that'd be numbered to 12. It took 4 before. Each of those was cut into 3 pieces, so 4 times 3 makes 12. How many pieces do I have in yellow there now?
9.
9, good. I had 3 before. Each of them got cut into 3 pieces, so 3 times 3 makes 9. So that picture is now 9/12. Do I have any more or less than what I did before? No, we have the exact same amount. 3/4 and 9/12 represent the exact same amount. They just look different. And the reason we were able to do that, to change the appearance without changing the value, has to do with this right here. Technically, that was 3/3. We multiplied by 3/3. The top number, 3, means we have 3 pieces. The bottom number means it takes 3 pieces to make a whole object. In other words, we have 1 whole object. This is what is referred to as a unity fraction. A unity fraction is a very powerful tool that we're going to use a lot throughout the next 2 semesters as far as converting measurements and other things like that. The unity fraction is equal to 1. The numerator and the denominator represent equal values. And it can be used to change the appearance of a number without changing its value. Because anytime you multiply or divide by 1, you get the same value, but you might change the appearance. Now up here, I had just picked the number 3, but a lot of times we need to decide what number is to be used. If I have 2/5, I might be told I need to change this into 40ths. Well, I have to figure out what was used, what was multiplied to change that. Well, what was the 5 multiplied by to turn it into 40?
8.
8, right? So we have to do the same to the 2. 2 has to be multiplied by 8 to make
16.
16. So 16 40ths is the exact same value as 2/5. Or if I have 3/7 and I need to change it into 28. What's that 7 multiplied by to turn it into a 28?
4.
4. So I multiply the 3 by 4 as well to get
12.
12. So once again, 12 28ths is the exact same value as 3/7. So what I'm going to have you do is I'm going to have you look at actually page 53. This is exercise 2-4. Problems 7 through 17, the odd. I'm going to give you just a couple minutes. Go through, turn each of those into the equivalent fraction that they're asking for. And we'll go over them in about 2 minutes. I realize some of you might not be all the way done yet, but that's okay. Let's go ahead and go through them quick. Number 7. 1/2 is how many 16ths?
8.
8 16ths. Good. Number 9. 1/4 is how many 20ths? 5. Good. I went the wrong way. Sorry. Number 9. 3/4 is how many 32nds? Pardon me?
24.
24. Good. Number 11. 7/8 is how many 32nds?
28.
28. Good. Number 13. 11/16 is how many 64ths? 16 times 4 makes 64. So 11 times 4 is
44.
44. Good. 15. 1/4 is how many 20ths?
5.
5. Good. 17. Now this one, it's a little confusing because you're looking at it and you want to change that 19/12, but we're not going to do that quite yet. 19/12 is how many 72nds? Well, 12 times 6 makes 72. 19 times 6 is 114, so 114 72nds. Any questions on those? Oh, the next step is going in the other direction. We had, 3 or 2/5, and we turned it into 16/40. Well, if I have 16/40 and I want to turn it back into 2/5, rather than multiplying both numerator and denominator by 8, I could divide. I can reverse what I did. 16 divided by 8 is 2. 40 divided by 8 is 5. And we've already said that 2/5 and 16/40 represent exactly the same value. Now, the trick here, the struggle, is to figure out what to divide by. And the answer is whatever either one of them, both of them can be divided by. We don't have to find, we've always been told that we have to find the largest number. It's called the largest common factor, or greatest common factor. It's not true. We can take something like 48/60 here. Some of you might look at it and see that both of them can be divided by 12. But really, if you don't see it right away, it's not worth the time to sit there trying to figure it out. We look at both of them and we see that both 48 and 60 are even numbers, meaning they can both be divided by 2. 48 divided by 2 is 24. 60 divided by 2 is 30. Now we're not done. We have to keep going. Both 24 and 30 are still even numbers, meaning they can still both be divided by 2. 24 divided by 2 is 12. 30 divided by 2 is 15. Now the 15 is an odd number. We can't divide that by 2 anymore. But if we look close, we see that both of those, 15 and 12, can still be divided by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. So 48/60 reduces to 4/5. I want to take a little bit of time here and talk about how do we know if a number is divisible by another number? Well, first of all, what does it mean to be divisible?
Broken down into groups.
Kind of. Divisible simply means to divide without remainder. So if I look at 24, 24 divided by 3 is 8. There's no remainder. So 24 is divisible by 3. 24 divided by 6 is 4. So 24 is divisible by 6. 24 divided by 5, however, is 4 with a remainder of 4. Or 4.8 or 4 4/5, however you want to work it out. 24 is not divisible by 5 because it has a remainder when we divide. Factor is just any number that it's divisible by. So let's take a look here at some little shortcut rules that help us quickly decide if a number can be divided by another number. Let's look at the number 2. How can we tell if a number is divisible by 2? It's even, yes. In other words, the last digit is 0, 2, 4, 6, or 8. So if I give you a number like 279,354, that is divisible by 2 because last digit is even. Anybody know the rule for telling if something's divisible by 3?
Adds up to 9.
Not 9, but I mean, 9 would work. If it does add up to 9, it's divisible by 3, but it doesn't have to be 9. The sum of the digits add up to anything that's divisible by 3. So what does that mean? Well, we go over here. 2 plus 7 is 9. Plus 9 is 18. Plus 3 is 21. Plus 5 is 26. Plus 4 is 30. Those digits add up to 30. Is 30 divisible by 3?
Yeah.
Sure it is. Yep, it is. So that number is divisible by 3. Now, if I didn't know if 30 was divisible by 3, I could have done 3 plus 0 equals 3, and that's definitely divisible by 3. For 4, there's a rule for 4, but it's really not necessary because, well, if I'm going to divide something by 4, I could just divide by 2 twice. And the rule for 4 requires us to memorize all the multiples of 4 from 0 through 100. I don't expect you to know all those. 5, however, is pretty easy. How do you know if something's divisible by 5?
And 0, 5.
Yeah, the last digit is 0 or 5. So this here is not divisible by 5 because the last digit's a 4, so it can't be divisible by 5. 6 is another one that we could just divide by 2 and then by 3. In fact, the rule is it's divisible by both 2 and 3. Not terribly helpful. Anybody know the rule for 7? I keep asking every year, hoping somebody will know it. As far as I know, there isn't one. So if you can come up with a reliable rule for 7, I'll give you extra credit for it, and I'll publish it and become famous and retire. And for 8, 8 is similar to 4. There's a rule for it, but it actually requires you to memorize all the multiples of 8 from 0 to 1,000. Don't expect you to do that, so we're not going to use the rule for 8. In fact, for 8, if you divide by 2 3 times, you've divided by an 8. 9 is the sum of the digits again. Only here it's not, they don't have to add up to something divisible by 3, they have to add up to something divisible by 9. So if I have a number like 279,351, if I add up those digits, 2 plus 7 is 9, plus 9 is 18, plus 3 is 21, plus 5 is 26, plus 1 is 27. Those digits add up to 27, which is divisible by 9, which means 279,351 is divisible by 9. When's the easy one? How do we know something's divisible by 10?
10 is 0.
Last digit is 0. Good. Perfect. Now, as we get larger than that, there are some divisibility rules for larger numbers, but they get increasingly more complex as we go, so they're really not worth it. The one for 11 is kind of painful. And at this point in life, you've got a calculator, you can just punch it in your calculator, divide by 11, and figure it out way faster. When I am reducing fractions, I am thinking those rules in my head. In fact, the first thing I usually look for is 10s or 5s, because all you got to do is look at that last digit. If it's a 0 or a 5, it divides by either 10 or 5. The second thing I look for is if it's divisible by 2, because again, you just have to look at the last digit. If that last digit's even, you can divide by 2. And finally, the 4, 1, 2, 4. That's great. Apparently you don't have to count to be a math teacher. The third thing, the final thing I look for is 3. The reason I wait till last for the 3 is because I have to add the digits up. So if I can divide out any 5s or 2s first, I have smaller numbers to add up. And then after that, I look for other things. Like 7s, 13s, 11s, things like that. Numbers that are prime. Prime means they have no other factors other than 0 or other than 1 in themselves. So by prime, I mean numbers like 13 or 17. Why would I not have to worry about 20? Well, 20 is a composite number. It's made up of smaller numbers. So for 20, if I've divided out 2s and 5s, I've divided out all the 20s. So let's take a look at reducing some. If I give you 28 over 48, what can both of those be divided by?
2.
I heard 2, so let's do that. 28 divided by 2 is 14. 48 divided by 2 is 24. Are we done, or is there something else we can divide by?
By 2 again.
We can divide by 2 again. Perfect. 14 divided by 2 is 7. 24 divided by 2 is 12. Good. Now 7 is prime. It can't be divided by anything other than itself or 1. So we have to stop there. So next, I want you to take a look in your book on page 54. Once again, problems 7 through 17, the odd. Do those in your notes quick, and we'll go over them in another minute or two. I said a few of you aren't quite done yet, but that's okay. For number 7, 2/8 reduces to what?
1/4.
1/4. Good. Number 9, 6/16 reduces to 3/8. Good. Number 11, 90 over 80 reduces to 9 over 8. Good. 13, 7/28 reduces to 1/4, a quarter. Yep. 15, 48 over 64 becomes
3/4.
3/4. Very good. And finally, number 17, 81 over 36 will become 9 over 4. Perfect. The next thing we need to look at is what happens when we have something like this, 45 over 7. That 7 is telling us that it takes 7 pieces to make a whole object. Well, the 45 means we have 45 pieces. In other words, we have enough pieces to make a whole object. In fact, we have enough pieces to make several whole objects. Well, how do we know how many? Well, I suppose we could do 45 divided by 7 on the calculator. If we punch that in, the calculator is going to give us something like, 6.4285714 approximately. Not horribly helpful. It does tell us that there's 6 whole objects there. But a more useful way to do that is to just use division and a remainder. 45 divided by 7. 7 goes into 45 6 times. That's our whole objects there. That's telling us that we can get 6 whole objects out of this. Then we do 6 times 7 is 42. So that 6 whole objects took 42 of those pieces. We subtract. There are 3 pieces left over. That's our numerator, 3/7 still. So 45/7 is saying we can get 6 whole objects with 3 of those 7ths left over. Or we might have like this. Well, let's do 34/9. So same thing, we're going to do a division and a remainder. 34 divided by 9. How many times does 9 go into 34?
3.
3. What is 3 times 9?
27.
27. So we subtract, how much is left over?
7.
7. Good. So this is saying we have 3 whole objects, 7 pieces left over. 3 7/9. I'm going to take a look in your book. We're going to flip to page 56. On page 56, numbers 19 through 29. Again, do the odds. I'll give you a couple minutes and then we'll go over those. Some of you are still working, but let's see how you did so far. For number 1, 14/5 becomes what? Or not number 1, number 19, I should say. 14/5 becomes well, 5 goes into 14 twice with 4 left over. So 2 4/5, right? So some vocabulary I want to introduce here before we go over the rest. This 14/5 is what's referred to as an improper fraction. I've never liked that name because it assumes, it implies that there's something wrong with it, that it's improper. And there's nothing really wrong with it. In fact, there are going to be times where we prefer to have the fraction in that form as we're working with it. But it is easier to visualize if it's in this form. It's called a mixed number. where it mixes a whole number and the fraction together. So then number 21, 63/4 reduces to what?
15 and
Perfect. 15 3/4. 4 goes into 63. Well, 4 goes into 6 once. That's 2. Bring down the 3. 4 goes into 23 5 times. There's 3 left over. 15 3/4. Good. Number 23, 79/16 reduces to. Perfect. 4 and 15/16. 25, 87/8 reduces to
1 and 7/8.
10 and 7/8. And number 27, 218 over 32.
9 over
9 and what? 30 over 32. Good. And finally, number 29, 451 over 64. Is 7 and 3/64. Now, many of your calculators have a fraction key. Most of them look something like that, ABC. Some it might look something like this, UND. Those fraction keys can do these reductions for you when you reduce the fractions or take them from improper fractions to mixed numbers. The last thing we need to do is go the other direction. If I have 3 and I need to turn that back into an improper fraction, how do I do that? Well, I have to take this whole number here, the 3, and I have to break it into pieces. How do I know how many pieces? Well, the denominator tells me that each whole number gets broken into 5 pieces. So that's 3 whole numbers times 5 pieces each is 15 pieces. Those pieces get added on to what we already have, the 2. 2 plus 15 is 17. So that 3 and 2/5 becomes 17/5. Or if I have 6 and 1/4, same thing. I have to break the 6 whole objects into pieces. It's going to be 4 pieces each. So 6 times 4 is 24. I add that to the 1 piece I already have. That's 25/4. So next, also on page 56, problems 7 through 17, the odds. Change those from mixed numbers back into improper fractions, and we'll go over those in just a couple minutes. Okay, once again, a couple of you are still working, but let's go ahead and go over what you have done here at least. So for the first one, 2.5 becomes
5/2.
5/2, good. 1 5/8 becomes
13/8.
13.
13/8, good. 1 3/16,
19/16.
19/16. 4 9/32.
137/32.
137/32, good. 4 times 3 is 128, plus 9 is 137. 5 31/32 becomes
160.
191 for 132, because 5 times 32 is 160, plus 31 is 191. And 43 4/5 becomes
19/5.
219, good. 43 times 5 is 215, plus the 4 is 219. So there won't be any homework today, just because the application problems on converting fractions is kind of corny. But one thing I do want to mention, the first quiz. I think all but one of you have submitted it, so I graded them and returned them earlier today. So you should have your quiz back. There's something called corrections on quizzes. What that means, or corrections means you need to redo each of the problems you got wrong. The biggest thing is when you redo them, you have to show your work. Now, if you can't show your work or whatever, maybe it's just a really silly thing you did, or just tell me what you did wrong. The problem, you looked at it wrong and you misinterpreted what it was asking for or whatever. If that's the case, just say so and then redo the problem. All right. Those I usually give you about a week after the quiz to turn those in so that you have time to think about them. I do want you to think about them on your own and work on them. Otherwise, if you can't figure it out, let me know and I will take class time to go over a quiz problem with you. But I want you to have at least a day to think about them on your own first, see if you can figure those out. And remember, you get back half your points. So if you had a 6 out of 10, that turns into an 8 out of 10 if you do those corrections. Don't guess. If you're not absolutely sure that you have them right on the corrections, don't turn them in yet. Either work with a classmate or talk to me. I'd be happy to sit down and walk you through those corrections step by step if I have to. So don't lose out on points by turning them back in and without being sure that they're correct. You have any questions? Okay, well, we'll see you all tomorrow. Tomorrow, you guys are all responsible for finding a spot to log in on your own. See you tomorrow.